Hi everyone, welcome back. Today we are going to discuss some MCQs from regression. First, let me give you a small recap, then we will do the MCQ. What is regression? Regression is used to find the relationship between two variables and to make predictions. Let's say you have bedrooms. From bedrooms, you want to know what will be the price of the flat. Okay, so two variables, one is bedroom and one is price of the flat. Now you want to know if the bedroom size is 2, then what will be the price? If the bedroom size is 3, what will be the price? If it is 4, then what will be the price? So simply from regression you can find their relationship and you can make predictions. Clear? This is the simple concept of regression. Now, it can be simple linear regression, it can be multiple linear regression. Simple linear regression means you have only bedrooms and from this you are trying to predict the price. But for multiple, you have bedroom, you have location, you have size, you have color and all these very different kinds of variables. Then it is called multiple linear regression. Okay, now let's start the questions, then we will discuss more. So what is the primary purpose? To predict a dependent variable based on one or more independent variables. These are independent variables and price is the dependent variable because price is depending on these variables. Okay. Second question. In simple linear regression, what is the relationship? See, y equal to a plus bx. Y is price here, that is dependent on what? On them. X is independent variable. So x can be anything like it can be bedroom, it can be size, it can be anything. Okay. B is the slope here and A is the intercept. Okay. So if I draw like this, then it will be like this. This is the intercept. This is the slope of the line. And this is x, which can be bedroom or anything. This is y, this is price. Okay, this is the regression equation. For simple linear regression. For multiple linear regression, then it will have multiple, let's say b0 x1, b0 x2. So here x1 is the bedroom, x2 is the color. If you add b0 x3, this is the location. Okay, A is the intercept, Y is the price. Simple. This is simple linear regression. This is multiple linear regression. Clear? Now, in linear regression, the dependent variable is also known as response variable. What does the slope equation represent? What is slope? What is B? Simply, let's say if I draw this line, this means if I change x from x1 to x2, from x1 to x2, then what is the change in y? Earlier it was y1 when it was x1. When it is x2, it is y2. So the change in y due to change in x is called slope. Okay. But when it's like change in y due to change in 1 unit of x, then it is called slope. This is the definition of slope. Okay. So you can explain that for changing this much in x, there will be this much of change in y. Okay. So the change in y for unit change in x. Now, if all the residuals in a regression model are 0, see, all the residuals are 0. So, let me draw something. Let's say these are your data points. Okay. Now what you have done? You have drawn a line like this. Now see, what is residual? Residual means you have predicted something and something in actual. What is your prediction? This is your prediction. This is the prediction, or we can say this is the regression line. So you have predicted this and in reality also this one. So there is no error. So very good. Error is 0 here. But for this data point, this is the real data point, but what is your prediction? Your prediction is somewhere here. So there is a difference between real and prediction. So there is an error. So this error, let's say E1. For this point, error E2. For this point, error E3. Error E4. So the difference between the real and the actual is called the error. and when you add all the error, then you get total sum of residuals. Okay, so the error is the residual here. Now our question is, all the residuals are 0. All the residuals are 0. When the residuals are 0? For this point, for this point, for this point. So all the residuals are 0 means all the points are lying on the regression line only, right? That is why all the residuals are 0. So you can say that the model perfectly fits the data because your model has predicted this one. And if all the real values are lying on this one only, then your model is simply perfect. So we can write the predictions perfectly fit the data. Fine. Now next question. What does a high R squared indicate? See, what is R square? R square is a value, or we can say that it is a number that shows how well a model explains the data. Okay, if R square is 1, that means the model explains 100% of the variation. But if the R square is 0, that means the model explains none of the variation. Okay. But if it is between 0 to 1, 0.75, that means the model explains 75% of the variation. 0.25, the model explains 25% of the variation. Okay. So R square is a number that will help you to say how well a model explains the data. Okay. And there is a formula to calculate it. Now the question is, then why adjusted R square? Now the problem with the R square is R square always increases even when you add more predictors which are unnecessary. Let's say you have predictor bedroom and size and you have calculated what is the R square for a model, let's say model 1. So it has given you R square 0.70. Fine. Now what happens? You increase bedroom, you increase the number of variables, bedroom, size, color also. Now maybe in reality color doesn't matter that much. But what your R square does, it will be increased. It will make 0.73 for second model. So problem is that here you have added some unnecessary columns. Okay, complexity of the model has been increased. But your R square is improving. So you will think that this model is better. But in reality this model is not better because you don't need this to calculate. Unnecessary you are creating complex. So your R square is unable to tell you that. R square always increases whenever you add some variable. It may be important or it may be not so important. Now to solve this problem, one concept came that is called adjusted R square. For adjusted R square, if it is 0.68, for model 2 it will become 0.65. So it will be able to explain that you have added something which is not necessary, which is not useful at all. Okay, clear? So the difference is that R square cannot tell you whether the extra added value is important or not, but adjusted R square can tell you that the extra added column is important or not so important. Okay, so that is why we try to calculate adjusted R square. Now let's solve the question. What does a high R squared value indicate? High R squared value indicate means a large proportion of variance in Y is explained by X. Okay. What is adjusted R square adjust for? It adjusts for skewness of data? No, the number of predictors in the model. Exactly. Okay. Now if adding more variables to a multiple regression model increases R square but not adjusted R square, what does this indicate? We have just discussed, that means that is not so important. So we can say the new variables improve. No, the new variables are not useful exactly because it is not increased. R square has increased but not adjusted R square. So we can say this is not useful because R square will always increase but adjusted R square will tell you whether it is important or not. What is linearity assumption? Linearity assumption means Y always changes linearly with X. There are many assumptions while using this regression model. One of them is linearity. Okay. There is a change, linear change of Y while changing in X. Now, violating the independence of error assumption can lead to underestimated standard error. That means every error will be independent. See, if your data points is like that and it is your prediction, this error doesn't vary this error. Or I can say that if you are trying to predict the bus delays, of every day of the week. So the residuals from Monday should not affect the residuals for Tuesday. Okay, the reason will not be similar. Fine. So we can say that this is called independence of error. This is also an assumption. That means assumption means that if this condition satisfies, then only you can apply the regression model. Okay. Now, which of the following is an assumption of linear regression? Residuals are correlated with predictors. Residuals have constant variance, that is homoscedasticity. Okay. So what does homoscedasticity means? Homoscedasticity means residuals have constant variance across all level of predictions. Okay. Residuals means actual value minus predicted value, and constant variance means the spread or the scatter of residual stays the same no matter what the input variable is. Okay. So the size of the prediction error does not change as the input variable changes. Clear? Simply means that it will look like random scatter. No pattern, no funnels, no fans, nothing. Okay, just random. Next question. In multiple linear regression, multicollinearity occurs when the dependent variable is categorical, nothing like that. Independent variables are highly correlated with each other. Exactly. See, if there are two variables, let's say bedrooms, size, color, price. If there are these variables. Now the thing is that bedrooms and size are dependent on each other. If I increase the number of bedrooms, automatically size will also be increased. So it is depending on this. So if there are dependents in this independent variable, then the multicollinearity occurs. Okay. So independent variables, if are highly correlated, then multicollinearity occurs, and it also cannot be applied for applying linear regression model. Now next question. Which of the following would not violate the assumption of linear regression? See, assumptions are linearity, second independence of error, one error should not be dependent on other, third homoscedasticity, that is the spread of residuals should be equal, sorry for the spelling, homoscedasticity. Okay. 4. Normality of residuals. That means residuals should be normally distributed. It should be a bell-shaped curve. Residuals. Okay. And no multicollinearity. That means independent variables should not be dependent on each other. Okay. That should not be highly correlated. Fine. So from here you can say that homoscedasticity. Now in simple linear regression, how many independent? I have told you only one. For multiple, more than one. Which method is commonly used to estimate the parameters? That is least square method. In correlation coefficient between x and y 0.95. Then what can we say about this one? We did in our last class. There is a strong linear relationship. Okay. So we have understood what is simple linear regression, what is multiple linear regression, and what is R square, and why adjusted R square is used. Okay. So bye for the day. Meet in our next class. Till then, bye. Happy learning.